Hello everybody, here we are, 3.3 solving right triangles. And what it means to solve a triangle is you need to determine all unknown sides and all unknown angles. So if we were going to solve a triangle such as this, we would need to determine each of the sides, the length of each of the sides, and figure out, each of these angles. And then that would be considered a solved triangle. So we need to use all the tools that we have, the Pythagorean theorem, our SOHCAHTOA, SOHCAHTOA, and the, a squared plus b squared equals c squared, and the fact that, angles in a triangle equal 180 degrees. We have to use all of these facts to solve our triangle. So here we go. We got a triangle here. We have side lengths 4.2 and 4.5. We need to find out this. This is a question mark to us, our hypotenuse, and we need to find out these two angles. Okay, so we can start with the Pythagorean theorem that a squared plus b squared equals c squared. So this information right here. So let's do it. 4.2 squared. So this side right here, 4.2 squared plus 5.2 squared is going to equal our hypotenuse squared. So let me get my calculator, I guess. Let's go Desmos. 4.2 squared, 17.64 plus 5 squared, 5.2 squared, or is that what it is? 5.2? Yep, 5.2 squared equals 2704. That's going to equal our h squared. Let's add those up. So 27.04 plus 17.64 equals 4468. So 44.68 equals h squared. And we want to find out what h is, not h squared, so we need to find the square root or take the square root. Remember, squaring and the square root are inverse operations, so these are going to cancel each other out, and we'll be left with the square root of 44.68 is going to give us the hypotenuse. So let's go. Square root 44.68 is 6.68. Let's do 6.68. So there we go. We have our first 6.68, or the hypotenuse equals 6.68. I guess we could call it, 6.7 if we want. And now we need to find the angles. So let's see. Let's find, angle C right here. We have the opposite. So we have what's opposite angle C, and we have the side that's adjacent to angle C. So I would use this info right here, that the tan of angle C, or tan C, I guess. I don't need to use theta. Tan C equals the opposite, 4.2, over the adjacent, 5.2. And now we just need to put that in our calculator. Since we're looking for an angle, remember we're going to use the inverse function. So inverse tan 4.2 divided by 5.2. Put a bracket around there, and we get, I'm going to round it up to 39 degrees. So let's go back to blue. Tan C equals 39 degrees. So we've got this guy right here too, 39 degrees. And finally, to get the last angle A, we can have 180 minus our 90 degrees minus 39, and we'll get the other angle. clear. 180 minus 90 minus 39 equals 51 degrees. And that's our kind of final piece of information. I'm reluctant to, there we go, erase because I erased some other information and it tends to pop back up when I press the erase. So there you go. We have all of the angles. They're 90, 51, and 39. We have all of the side lengths, 4.2, 5.2, and 6.7, let's say. So that is considered a solved triangle. Let's do the next one. Looks like we have an angle. We have one side length, so we need to find two side lengths and an angle. We could start with the other angle. So we have 180 minus 90 minus 38, and that's going to equal 52 degrees. So we know that right there is 52 degrees. And now say we have an angle, we have the opposite length, we need the adjacent side. So we can say tan angle 38 equals opposite 8.3 over we don't know. And I'll show you all the steps, but remember I've been telling you if you have, tan across diagonal from our x, you can swap them. But I'll show you the steps. So it's going to look like this, that it would be like tan 38 times x equals 8.3. We want the x by itself, so we can divide on both sides by tan 38, tan 38. This is going to become 1, and we're left with x is going to equal 8.3 divided by tan 38. So let's go 8.3 divided by tan 38, close bracket, 10.6. So x equals 10.6. So this side length here, I'll do it in orange, is 10.6. So now we have both the legs. We can find the hypotenuse with the Pythagorean theorem, or we can also say, okay, look, we have an angle. We have the opposite. We want the hypotenuse. So as you recall, we have the opposite. We want the hypotenuse. We're going to use sine. So we can use sine 38 equals opposite 8.3 over we don't know. And let's do the swap this time. They're diagonal from each other, so we can just swap sine 38 and x. So it's gonna look like this. X equals 8.3 divided by sine 38, and let's see what we get. 8.3 divided by sine 38 bracket 13.48, let's call it 13.5. X equals 13.5. And there you have it. 13.5. And we should ask ourselves, does this make sense? Yeah, I would say this makes sense. It's bigger than 8.3 and 10.6. It's not drastically bigger. I would say that makes sense. So now we have all side lengths. We have all the angles, and this is considered a solved triangle. So there you go. There you go. These next ones aren't necessarily solving a triangle. They're asking us for a very specific thing. Determine the length of CD. So determine the length of this one right here. But we might need to kind of move around in this triangle and use what information we have to find out what information we don't have. So let's see. We don't have much in the triangle that we need. We don't have any of the angles. Well, none of them are labeled, and we don't have the side lengths. We do have this information right here, that this angle right here is 63. And if this angle, this whole angle is 90, we can find this angle right there by going 90 subtract 63. Okay, we can do it in our calculator if you want. You can do it in your head. That's wonderful. 90 minus 63, 27. Beautiful. Oops. equals 27 degrees. So we know this angle right here now is 27 degrees. Okay. But we still can't really use that to determine this length just yet. But maybe if we figure out this shared line right here, we can use that kind of information about the hypotenuse and this one angle to find the length of CD. So let's first use 63 and the angle that is opposite it to find the hypotenuse. So we have an opposite length. We want the hypotenuse. So we are gonna, I'll write this again just for your reference. You can rewrite it as many times as you want. We have the opposite. We want the hypotenuse. We're gonna use sine law. So sine 63 equals opposite 17.2 over the hypotenuse. We don't know. They are diagonal from each other, so we can swap them. We can say that x equals 17.2 divided by sine 63. And let's do it in our calculator. So 17.2 divided by sine 63. We get 19.3. So x equals 19.3. So this length right here, 19.3, our hypotenuse. And yes, that makes sense. It's bigger than 17.2. I'd say that makes sense. And now we have an angle. We have the hypotenuse, and we want this side, which is the adjacent side. It's touching the reference angle, and it's not the hypotenuse. So we have the hypotenuse. We want the adjacent. We're going to use cosine. So cosine 27 equals, we don't know, over, so adjacent over hypotenuse 19.3. And what that's going to look like is that cos 27 times 19.3 equals x. So let's do that. Cosine 27. Make sure you close your brackets. Times 19.3, 17 point, let's round it up, 17.2. So x or CD equals 17.2. I mean, maybe we could have known that just by looking there, but there you have it. I guess by virtue of it being a rectangle, maybe we also could have just figured that out an easier way, but there you go. Okay, let's move on. Oh, one piece of information that's that we need to know to determine kind of some future questions is the difference between the angle of elevation and the angle of depression. So not a stat angle, but something that goes from a point up and something that goes from a point down. I've seen it on notes, and maybe this is helpful. I'm not too sure, but this could be like a person on ground level, a person. Wow, that's an awful drawing of a person. A person looking up, and this might be like an airplane looking down. Okay, now another excellent drawing of an airplane. And the airplane looks down, or you could say that as a bird. You know, I don't know what I'm drawing here, but angle of depression is an angle that goes down relative to the horizon, and angle of elevation goes up relative to the horizon. So I don't know if either of those bad drawings are helpful. There you go. So let's look at a question and figure this out together. So looking down from a cliff, so they're looking down relative to the horizon. This is an angle of depression. A man 1.7 meters tall, so he's right here, 1.7 meters, 1.75, meters tall, looks down at a river side, the near side of a river at the angle of depression of 35.6. So this right here is going to give us a 90-degree angle. If the near side of the river is 40 meters from the base of the cliff, so this is the near side of the river right here, and it's saying this is 40 meters from the base of the cliff, what is the distance between the person's line of sight and the near side of the river. So we're trying to find out this person. Sorry, I got cut off. So we are trying to determine the length right here. So we're kind of trying to find, well, we are trying to find the hypotenuse of a triangle that looks like this. And that's the edge of the river right there. So we have this angle, the angle of depression, but we need to know what's this angle inside. And we could find that by remembering that we can go 90. We have a 90-degree angle right here, minus 35.6. And we should get that other angle tucked in there. I think it's 54 points. It's the end of the day. 90 minus 35.6, 54.4. So this angle inside there is 54.4. Okay, and now we have the opposite. We have the angle that's, or the length that's opposite. We have an angle, and we want to find the hypotenuse. Remember, I can write it here. So, TOA. We're going to use sine of 54.4 equals the opposite, 40 over the hypotenuse, which we don't know. And now you can swap spots of sine and the x, or, maybe I should show you the steps again just so you understand them. This means we're going sine 54.4 times x equals 40. To get the x by itself, we need to divide by sine 54.4 on each side. This becomes 1, so we get rid of that, and we're left with x equals 40 divided by sine 54.4. So let's go 40 divided by sine 54.4. 49.2, let's say. So x equals 49.2 meters. That's our hypotenuse right there, 49.2 meters. And now it asks, how high is the cliff? This is a little tricky. There's one thing that we have to consider, which is that we currently have this triangle made with the sight line of the person, and they are standing on top of the cliff. So whatever we get, we're going to need to minus our person's height from that. So how high is the cliff? Let's determine this side right here. Let's determine that side. So we can use the Pythagorean theorem. We can use the fact that, we have the opposite. We'd like the adjacent. We can use the tan ratio as well. So we can say tan 54.4 equals opposite, 40 over the adjacent. We don't know. And we can determine it that way. That means that x is going to equal 40 over tan 54.4. So let's do that. 40 divided by tan 54.4 equals 28.6. So x equals 28.6. And now, go back to lots of colors today. We have 28.6 meters, and we need to minus the height of the person that's looking. So we have, let me see if I can. No, I think if I erase, it's going to reveal the answers from before. So we want this height right here. This whole thing is what we've just determined, but we need to subtract the 1.7 to get the height of just the cliff. So let's go 28.6 minus 1.75, and we get 26.85 meters. 26.85 meters. Okay, let's do the last one. There's one thing you need to remember, which is how you find the volume of a triangular cylinder. But first, I guess let's find out our unknown length. So we do want to determine we have an angle of 7 we have this side right here, and we're going to want the opposite side, because if we want to be able to find half of base times height times width. So if we had, a rectangular prism like this, it's just this side width times height times this one right there. So just all the 3 dimensions together, but because we have a triangular prism, we're going to be slicing that in half. This is the divide by 2 part. So we need to find this length right here to be able to do all 3 dimensions. So we have an angle, we have the adjacent side of the angle, and we want the opposite. So let's go tan 7 equals opposite, is what we don't know, over the adjacent, 13.4. And now this is going to look like this, that x equals tan 7 times, well, I've been using a little dot, but that's okay, 13.4. And let's do that in the calculator. Tan 7 times 13.4 equals 1.6. Let's leave it at 1.6. So here we go, 1.6. And now we can determine the volume of this wedge by our formula, half of 1.6 times 13.4 times 2. And let's do it. So I'm going to do 1.6 times 13.4 times 2. Beautiful. 10.88 divided by 2. And we get 5.44. So I'm going to go 10.88 divided by 2 equals 5.44 meters cubed. That's squared. Cubed. There we go. Thank you so much. I'll let you know what textbook questions I'd like you to do.